Hi, students. So I went ahead and made a part two audio lecture that follows up on bivariate associations, but specifically on how to interpret um, levels of significance. Okay. When you are running correlations on SPSS, you are given a Pearson correlation coefficient that tells you the direction and the strength of the relationship between your two variables. And underneath that number on the output is a value that denotes the level of significance, okay? Now, it's important to look at that value in conjunction with your correlation coefficient because that tells you something important. If the correlation is statistically significant, then that means that what we are seeing in the data, the correlation between two variables, is not occurring by chance, that it's not some glitch in the data, that it's not luck, that there is something going on with those two variables that can be depicted and studied in real life, and that the effects are so sound that we know they are not just happening out of sheer luck, okay? Now, I went ahead and made a handout. This is on Blackboard, okay? This is a follow-up handout to correlations, okay? Specifically tending to levels of significance and p-values, okay? So again, statistical significance tells us that what we are looking at is a solid finding and that it's not occurring by chance or as a result of a glitch, okay? So when we are statistically assessing variables, the significance is indicated by a p-value, okay? This p-value is a number that tells us whether or not the relationship is significant, and depending on where that value sits on a range, it indicates how significant the relationship is, okay? So when we are interpreting a p-value, okay, what we want is a small p-value, okay? A smaller p-value is a good thing, okay? A small p-value reflects a stronger and more significant relationship than a p-value that is larger, okay? Now below you'll see four different guidelines for p-values that is commonly used in research, okay? These denote the levels of significance along with the symbols that we use to associate the reading with that p-value, okay? Now, this p-value here, letter A, is the strongest and most significant level, okay? So what this is saying, what this formula here is saying, is that a p-value that is less than or equal to 0.001 is highly significant at the 0.001 level and is denoted with 3 asterisks. So when we are writing research and we are trying to explain or discuss a finding that we had, we can use 3 asterisks instead of having to say, oh, the p-value is less than or equal to 0.001. If we use the 3 asterisks, this is a standard way of denoting significance so that every reader who sees it understands, oh, okay, that's a very significant relationship, okay? So again, this is the most significant level. So any p-value that you see that is less than 0.001, you know is highly significant at the 0.001 level and gets 3 asterisks, okay? All right, next is B, okay? This is the next level, it is less significant than A, but it still is pretty strong. And it is a significant effect, okay? It's just not as significant as letter A, okay? So what this is saying is that this is a p-value that is less than or equal to 0.01, okay? If the p-value is less than that, it is significant at that level, okay, and is denoted using 2 asterisks, okay? So again, a p-value that is less than 0.01, okay, but greater than 0.001 would fall in the B level of significance, okay? All right, moving on to C. This is the next level of significance, okay? Again, it is less significant than A and B, but overall we would say that it still reflects a moderately significant effect, okay? So if we have a p-value that is less than or equal to 0.05, then we know it is significant at the 0.05 level, and we can denote its significance using 1 asterisk, okay? And finally, we have letter D, which is the last level of significance. It's the least significant level, but remember, it's still significant. It's just not as significant as all the ones above it, okay? So D is less significant than A, B, and C, but it's still significant. So we can say that this level reflects an effect that is borderline, but still statistically significant. So any p-value that is less than or equal to 0.10 is significant at that level, and we can denote this significance level using this symbol here. It's like a little cross, okay? All right, so that sums up significance. So now we're going to look at a really quick output, okay, a correlation output, okay, to sort of better understand how it is we utilize p-values, okay? So when we run correlations for 2 continuous variables, this is the output that we see, okay? So this output here is showing results for the correlation between height and weight, okay? When we look at the output again, right, we're looking at this Pearson correlation coefficient here, which is 0.513, okay? It's a positive coefficient, and it's pretty strong, okay, moderately strong. So we can say that results indicate a strong positive correlation between height and weight, okay? The correlation coefficient is this, 0.513, okay? Now, beneath this value, you have the sig2 tail. That is your p-value, okay? So the p-value here is 0.000. If we go up to this chart here, okay, we can see that 0.000 falls under the A level of significance because it's less than or equal to 0.001, okay? So we know that this correlation is strongly significant at the 0.001 level. Now you'll see on SPSS, it gives you 2 little asterisks here. Don't go by those asterisks. SPSS uses a different standard. So you always want to interpret significance using this here, okay, and the guidelines that we discussed up here, okay? Now, in your homework assignments, I'm going to ask you to properly interpret your findings, and I always stress I want it in proper statistical terms, okay? I want you to interpret this properly in statistical terms. So here's an example of how you would interpret this this correlation and the output, okay? You can say results from this output indicate that height and weight are strongly positively associated with a correlation that reflects strong statistical significance at the 0.001 level, okay? And at the end of that sentence, you are to include the information here in parentheses. And this is basically your correlation coefficient, okay? You're showing your correlation coefficient R equals 0.513, and then the level of significance, which is 3 asterisks, okay? And then I want you to give a substantive interpretation of what all this statistical lingo means. So in layman's terms, if you were to explain this to a 7-year-old, what would you say? This means that as height increases, weight increases, okay? This relationship is strong, and its significance level tells us that this effect is not occurring by chance, okay? All right, guys, so that concludes this brief lesson on statistical significance. You guys do have a quiz coming up on Friday that is on your syllabus, so be sure to look at that and access it when it opens up on that day, okay? We will continue next week, week 11, with bivariate associations, looking at cross tabulations and chi-square test of independence. So you guys study hard, stay safe, and I will see you next week.